Alright, so for today, we're going to be working on a BMP encoder. First, we're going to do it in C, and then we're going to do it in Python. There's a reason for this. Now, for my own interests, I want to do it in C. And obviously, going for C first to Python is going to be a lot easier because it's the same language to binary data. Right? It's much easier when it's, for example, handling. Say, okay, I want to write 4 bytes, right? That's way easier to do in C. Python is not really made that kind of thing. You can do it, but it's just made for it. So yeah, and is right. You can get to the music that work for me. So actually, like, hey, back on you. Meta building where you're watching. I think it's I really here around one side. It's the video very straightforward. I haven't seen this, but I'm not working in a file for my but it gets some metadata about the image for example, the info editor and stuff. Table. And after that, straight up, right? Okay. First, right? Do this right. So, right. First, I was trying to. What was that saying? Yeah, just delete that. Delete that. Oh my god. Shit. Well, this file was right, not deleted. Guys, we'll see. I was just looking at like, making sure that this particular structure is aligned properly. First, it's 4-bit with an any pen. It wouldn't really matter because it's structure defined once. Anyway, on the side was some comments about how to set this field. If, for example, why it says data offset is 0. I think it's supposed to be for reserved. Yeah, so I'm not sure what happened there. Anyway, okay, so I lost a couple lines of code, but I don't think it exactly matters. It was really more me just playing around. So, okay. Anyway, let's just go ahead and jump right into this, right? So, I'm going to remove this comment. I'm going to paste it here. There we go. Now, even though I know that this is going to be for making this myself, I'm making it for the Linux system. So I really just put signed int, but I figured maybe this time I'll go ahead and go ahead and use the uint type to guarantee that it's such size, right? I think this way, if someone's on system, they can also use this, for example, which is I think is cool. So, all right. So as per My resource over here to the side. I need to eh, some times in this. I don't feel like you in the times. Also, these are going to end up being for course. As soon as I start doing it, I'm going to reach the unsigned short. So at least everything I'm going to do is do it. So now it would be smart, but not going to bother doing decompression right now. Um, yeah, I mean, so it's not my concern right now. That's going to be for another time. And do the quite a bit of the decompression we've done right now. We're really more into just straight up reading BMP files. So now later when I do the Python thing, I don't this that's the point. That's not programming like that's maybe takes Windows library, right? Which again, but this is more for exploration and programming and thought and so it's a recreational program. Okay, so the color table is just straight up not going to even be populated. It's going to be straight up zero, I believe, as per the note on this resource. It says it's only present if there's less than 8 colors, but I can do the full RGB. I believe that's on which field is that from? I believe that comes from. Let me go ahead and open this scan real fast. Yeah, bits per pixel. So I'm going to put 24 the RGB. So byte for pixel. What's funny is that the colors are backwards on this one, so I know we always say RGB. In this case, instead, it's BGR. So blue comes first, and the green pixel will come first, and the red pixel comes first. Yeah. All right. Now, from the case, the particular task I need to perform specifically is I want to write and you basically need to draw a rectangle with some colors inside of it is the gist, right? Uh so uh, some functions I want to go ahead and get done are going to be, well, first let's finish the struct, right? Getting ahead of myself. And then pixel data, right? So pixel data, I'm not going to make a struct. I could do a struct, but the problem with the struct is that it's going to have padding, which will make it will actually force more space to be used, which is just bad, right? Every basically every pixel would have an additional um yeah, every pixel would have like an additional 1 byte, just that's wasted, but there's gonna be a lot of pixels, so it's just a lot of wasted memory for no reason, right? Instead, we can just go ahead and grab. We can use an unsigned character pointer, right? Because since it's 24-bit RGB, uh, every pixel is 1 byte, right? And it's unsigned. Eh. So what I can do is I can just grab three at a time, and then that's it. But otherwise, I'm using a struct. Like I made, for example, a struct a 24-bit pixel, right? And then I have unsigned character uh, green unsigned character, red unsigned character, blue. Right? Okay, I used 3 bytes, but that's not 4 byte aligned, so it's going to add a byte of padding, which is just silly. All right, so I can type. Well, I guess actually, this would be a uint 8 pointer, right? It would be an unsigned character pointer. I've forgotten. This time, I'm trying to go ahead and use the std int stuff, right? Okay, so I guess now then, probably just want a function to initialize this, and it should just take a couple of things, right? Um, it's gonna have to take the height. It's gonna have to take the width, for example, right? Um, Now I don't know what this pixels per meter thing is. I don't even know that's a required field, or if there's some sort of math I need to perform to determine that. Right. So that's already something for me to look up later. Anyway, though, so let's go ahead and make a function to return a pointer to a BMP struct, right? So mm, all right, so let's see. What else do you need to provide minimally? I think I'm not going to ask about um, bits per pixel. I think I'm going to force that to just be 24 by default. Um, yeah. So I think I'm just going to leave this. I think I might only require these two fields. And then you can go ahead and draw it manually. And then, I mean, you get a pointer back to it. So if you really want to change the thing, then you can. I think, let's see. Maybe it'll become more, at least me what change I need to make as I write this function. All right. So for now, I mean, this is just the header file still. So we'll have that. Let's see. Um, Probably make a function to draw a line, uh, to draw a horizontal line, I suppose. And now let's start small, right? First, we'll just make a function to put a pixel. So of course, it will start at the buffer. Yeah, so we'll make a bunch of little functions to give you control to kind of do things exactly as you want. So as I'm seeing it right now, probably then what that means is maybe so. Let's make the font bigger, so make it easier to read, I guess. All right, so there will be a function to put a pixel at an offset, right? Um, Place it at like an X, Y coordinate kind of thing, right? Then there will be to horizontal line, function to draw a line. For example, you might want to draw a square or some other shape. But in that case, um, mm, I think that's the same thing as just calling the line function a few times, right? You would draw your so the horizontal line is going to be at an offset, right? And okay, yeah, so let's just go ahead and do this, all right? Uh, and so I guess I should return the offset at which it ended, right? So I'm going to have this return. It depends to be very large, but I don't know what system the person is having, so I'm going to use a size t. So that the offset will be in case it's like in case the file is so big that we're dealing with values that you know. So yeah, I'll go ahead and do that. So I'll use a size t because I can't say it's a 32-bit, that I can't say it's 64 bits because I don't know. It's based on the person's computer, so at least this one will change accordingly to the computer. So what I'm going to do is it's going to return a size t, where it's going to return the offset, and this will be BMP. Um, these will all return this one, but I guess this one, for example, for the pixel one, this will put a so it'll give you the offset to right to the next position. It's not exactly a very useful return value, but I'm going to do it anyway, right? Uh, And then this here, you'll just define your pixel values, right? Similarly, I want to do BMP and put the pixel SY, right? And it's based at the coordinates, right? Um, it just needs to have an offset as well, right? Um, okay, so similar, this will be to return, so we'll return the offset at which the pixel can be found, and it will take a particular row and then the pixel value, right? And so this one also needs to take a row and a column will be a starting point, right? And then figure okay. I think like OBS had a kind of bit of a heart attack for a little bit. It's kind of nuts. Okay, this did some moving around on how this how my stream is being encoded. I'm hoping that by doing that, it's going to improve any weird little hiccups or anything that might be happening. So I'm going to resume where I was. All right, so I'm just trying to decide like how these functions should operate in terms of what they should return and what they should what you need to provide to it. All right. This is meant, uh, you still have to use the library for pictures. This is not like a Photoshop tool ever meant to be anyway. the graphic that I need to generate is always near. Um, yeah. Okay. So yeah, I don't think I'm just trying to think. I don't think anything else really needs to happen much uh beyond. I think it seems primitive. I might get a little bit fancy because I know one thing I want to do later is gradients, and a gradient can be easily defined, right? For example, you give your starting value, you give maybe an intensity, how drastically you want it to change, and the color that it should it terminate at, right? Um, Now I think that could just be an option that's given to the line functions, or maybe there could be a new one where it's like draw a line with gradient. I don't know. Um, Maybe it could take a gradient struct, although I think it's just getting a little bit too silly with the whole object-oriented nonsense. I think it could really just be, hmm. Well, okay, first start small and then build big. Right, that's what C is all about. Um, so let's go ahead and just do that. All right, so we're doing the line function for horizontal line now, right? So you need the pointer to BMP, um, and of course you need to specify the row that this should be in at, and the column should be in at, right? And then drawing a line across the entire image is easy because what do you call it, right? So if drawing a line across the entire image is easy because, for example, you would be defining this, right, the image. So if you want to draw a line across the whole thing, uh, then you would specify the row and the column at which it starts, right? And then you would specify its length, and its length would be the entire width that the picture has, and it would start at the beginning of that column of that row, right? So suppose uh, the logic is really the same between the vertical and horizontal line functions. So honestly, then um, I may just have this take uh, an additional parameter to specify whether or not you want this line to be drawn horizontally or vertically, right? Now, I know that for the horizontal case, there is one special consideration, and that is that I believe the each row must also end with four byte. It must be 4 byte aligned, right? Right here it says each scan line is zero padded to the nearest 4 byte boundary, right? So, for example, and it goes on further, so I'll just use their example because these are the people who know what they're talking about, whereas I'm more of just the learner, right? So if the image has a width that is not divisible by four, for example, a number such as yeah, so this actually these one and take a enumeration, I suppose, right? So I'll make it it'll be like I don't know, like it's really just be more just like direction, right? I mean, really honestly, I could even just have this. I could have a define macro. What is this? Why not? Um, all right, so I will only have one function, all right? And this will no longer be draw horizontal line. Instead, it will be draw a line, which is actually much more simplistic, right? Now it's just draw a line, right? Okay, cool. Uh, so now, then, what this needs is the type of line to be drawn. I suppose let's go here. I think this is kind of where you put the repetitive information. I think so. I think it's I think better front logos instead. Everything else might be changed all the time. Right? I think most of the time it will be the same pointer to a BMP, and most of the time you're only going to say that line. All right, that's my function. All right. I also want to have a BMP delete and a BMP write. Although you could do it, without it, but I think actually it'll be nice to have a BMP write function, right? Uh, it'll be really easy. Basically, I'm just going to write all these fields to a file, uh, and then I have to write the pixel data. So maybe for that reason, I don't know. I mean, you have the width and the height, so maybe it would be good to have all of the pixel data at once. That is, I could just count the lines because I think I don't know. Let's see. It really is just a one-dimensional array because we know predictably um how to chop things, but it's really the padding that's concerning me because you have to think about uh when the padding occurs. But really, the padding would have to occur on every row. So it's just the amount of padding that's necessitated by the row not being divisible by 4 uh, times the height. So I think you could actually determine pretty easily where the end of the data would be. So I don't think there needs to be an additional variable. I think that can just be it, right? But and I suppose no. Yeah, so there still needs to be because we're just writing to pixel data over here, right? We're not writing directly to the file yet. It might be better for memory, I don't know. Only because you potentially need a whole lot of memory. Um, and I know that there can be some weirdnesses about trying to allocate too much memory on a C program. I don't know. I've never really programmed anything before where it needed such a crazy amount of memory, right? So I don't know at which point it starts getting weird and you have to start doing other things like memory map or whatever. But yeah. So for example, I think there's a heap overflow. The thing you can get right. Um. Anyway, I'm going to also say because I don't have to write it right yet, so I can go ahead and say eh, so this will return how many bytes were written, right? And it'll be BMP write to file, right? Um, this one will demand a file descriptor. I think that's fair, not to expect this thing to open the file for you. Um, yeah. So first, of course, it will take the BMP, then it'll take the file descriptor. I think that's it. If you try to write the whole BP, it returns you how many bytes are written. And it's like you determine if it succeeded because you should expect that it writes a certain amount of bytes. Um, and if it doesn't do that, then then you know that it did not go as planned. Right. I think with that, that's all we need. It's actually relatively small, at least in terms of the header items, right? But I'm sure the code will expand greatly. Um, okay, so of course now what I need to do is need to implement all of these functions, right? So I'll yank this. I'll make a tab new, and I'll edit um, libeasybmp.c. And let's go ahead and paste these, right? But first, also, I always make a build script. Now, I know I could use what do you call that? Makefile, but I don't think this is really that serious. I like to do it in Bash as well. Okay. All right, so we'll do this in Bash. I guess what I could do is touch. Now I can edit build, right? Just because I want the syntax highlighting. I noticed that doesn't until I add the shebang, it doesn't know how to do the syntax highlighting. So, all right. So first, of course, I'm just going to say let's do it. So it's going to say compiling. What do you call it? So it says compiling lib easy BMP, right? And actually, I don't want a new line either, right? Um, want the object. I'm being super pedantic, I know, but I just I want I don't know. Okay, so for now, all it has to do is this. And I'm gonna go ahead and add all my flags, right? And I think there's also a few more that I ought to add. Let me go ahead and check real fast. Uh, let's see. Useful C, GCC flags, right? Here we go. These. Um, I think I want the conversion warnings as well. And also, I guess unreachable code as well, because then you're just writing strange code, right? Now, I don't think this will work right now. But so nothing always is perfect the first try necessarily. So if it doesn't work the first time, I'm just going to go ahead and modify it, right? Anyway, back to this. Okay, so this is my function. So again, now I can go ahead and start actually writing it, right? So the first concern is I'm going to try to make a struct BMP, right? And we'll try to allocate memory for BMP, right? Now, if the BMP pointer is null, I'm going to throw an error. And of course, I now return a null pointer, right? Okay, so and then what I want to do is I want to just start setting the fields of the BMP, right? So we already know that the signature is going to be equal to BM, right? So I can just write that directly like that, right? So I'm going to say this is the activity of initializing the header. Okay, so now we're going to go ahead and set the side equal to in bytes, right? Now this depends on the width and the height. If the width and the height are not divisible by 4, um, then that's proper. Okay, so there, I think let's just go ahead and do some math, right? Because I could just do a modulus, but then like modulus is a bunch of arithmetic, whereas maybe, for example, there's a fast way. So if it's 2, then it's not divisible by 4. If it's 4, it is. If it's 6, it's not, right? Um, if it's 8, it is. If it's 10, Hmm. And in binary, let's see. I think basically then, if the first two bytes are 1, then it cannot possibly be divided by 4, I think, right? So, for example, let's just show invalid cases. So these are invalid cases, right? And then what follows is valid cases. There's some things missing here. I'm going to put them in a second, but let me just show something. So this is obviously invalid, and this would be this has to be a 32-bit integer, right? So I'm just going to go ahead and do okay. So this is obviously invalid. This 0, 'cause you can't have a image with no rows, right? That's ridiculous. And 1 is this guy. 2 is this guy. And 4 is this guy, right? Just to give an example of the powers too. So power of I don't know, this would be the power of 7, right? 7, 6, 5, 4, 3, 2, 1, 0, right? Why did I go to a new line? Okay, that was weird. The thing like wouldn't let me change it. All right, so this would be the power, right? Okay, so one thing I'm noticing is that these guys cause problems. These particular bits cause issues. So as we'll see here, then, right? Those bits are not going to be on. If any of those two bits are on, I think it creates a problem. One thing we already know that if this bit is on, then it is the only bit that contributes an odd number 1, right? Everything else is even, so any odd number has to have this. So this immediately is a problem. Anytime this is here, it's an odd number, and there are no odd numbers that are divisible by 4, right? Now 2 is not necessarily a problem. But I mean, 2 itself is too small, right? And it's going to make the 2 is contributed, then the number for it, what I believe, right? So, for example, so it's power 8, or it was 8, so the power 3, right? And this is a symbol. Let me see, what can I get like an emoji, right? Okay, so and this is good, and this is good, and this is good, right? Um, and so will this number, 32, right? I was put a 1 there instead. And these are bad, right? These are bad. But maybe they left out other numbers, right? So, for example, we can go ahead and put 3 here now. All right, it would be valid because 3 is not divisible by 4, right? So it can't match a 4 byte alignment. So, because in order to determine the overall system picture, I need to include the size of all those metadata, right? How many bytes those are, I was just really like, I had a new list out. But I also want to consider, now I'm saying this slider bit or cool. So I know that every pixel contributes right? So the row width multiplied by 3, but that doesn't capture the padding, right? So I'm doing this ahead of time to capture to understand how much padding is also included there, because otherwise I can't determine the file size, right? But I also want to do that fast, just because I think it's fun, right? Like, you know, I could do it slow. I could just say the modulus, but I think there's a better way. I think I can just apply these masks really fast, as opposed to doing a bunch of because I think modulus is division, right? So modulus would actually be like a very slow CPU operation, right? Let me look that up. I want to see. 1 second. Yeah, I mean, modulus has to be slow. It's division, right? It's integer division. It has to be a slow operation, I think. So if I can just, if I can just put my little thing there, I think it's cool. I think it's fun, right? I know it might seem like, oh, this guy's wasting time, but like I want to write something cool. I want to write something fun. I want to be clever, right? I mean, if I didn't care, well, I don't know what the I really don't know what the point of writing in C would be, right? It would just be like, why don't you just go write in Python then or something, right? Say that. Meanwhile, later I'm going to go ahead and do the Python side. That's what I have to use at work. But you do like, right? So it's just a long road. Which of the topic does right? And it's here for 5, right? And then the 5 would be that this is on, and these are on it. So it's a common denominator where wherever any of these are on, then it's issue, right? So I'm thinking of making a bit mask where all of these are 0, and just checks, and these are 1, right? Um, because that way I should get 0 back if it's okay and it's divisible by 4. And if it's not divisible by 4, then I should get any number that's not 1, whether it's 3 because both of these are on, or not 2 because this one is on, or that's 1, this one is on, or whatever. Um, right. And this factor is 0 check because if it's 0, 0, that's a sole problem. Um, so first check this is 0, which is fast operation anyway, because 0 is invalid, right? Then I'll do the bit mask, and then I'll expect it to be 0. That's the correct, the acceptable value, right? So the next acceptable value, which I believe will follow the pattern still, if I had 6, right? And after 6, it's like on. This is right. And both of these on, it's right. I think this can be on. So now I'll go ahead and do the same thing with 9 and 10. Sorry about for 12 is valid, I believe, right? You know, yeah, 12 might actually break my logic because 12 is 4. So we'll see how that goes for me, right? And basically what I can do is, and then I was, opt for the more simple. I think I'm just using thing, right? Okay, so really can't be. And we still see my pattern working here, right? That's an 11. Well, these are on, and then 12. Yes, 12 actually. No, because 12 is still a valid number, right? And again, I'm saying that with 12, none of these are on. Right. Instead, I have these two are on. So once again, 12 is an accepted value because it's divisible by 4, right? And these bytes are not on. So now similarly, I guess if I go ahead and do 13, whoops. Let's just go ahead and do 13, 14, and 15, right? Okay, so now 13 is a problem. 13 is divisible by 4 because this byte is on. Actually, I don't need to get the emoji better because of this. All right. 15 problem, not 16. Right. 13 has this byte on, no problem. 14 has that bit on, right? 15 has both of these bits on. And it seems okay because those are on. Okay, so I think that I'm correct. I think that there's a fast way to do this. It's just to check that um, if these bits are on at all, because these bits are a problem, these are the sections of the number not deal for, right? So okay, so determine if the image require padding on scan lines, right? So let's see. Now I guess I also need to do this for example, right? So I'm going to take let's go take these guys, right? I'm going to examine just to make sure writing bit math is always going to be super hard for me. Doesn't even make sure maybe a bit slow brain. Yeah, I want to see visualized. Right. So okay, so first off, this guy, right? Now saying that if any of these are on, then it's a problem. So it has to be not A and not B, right? So I'm going to do, in other words, A or B is a problem. Yeah, so it's just it really is just or, right? I'm doing a bitwise or, I think. Um, well, no, I guess I'm doing bitwise and because I don't want these guys are not valid, right? These guys all need to be 0. So M is the mask, right? And this will be and. Um, I think that I think that will give me what I want, right? So I'm going to put the result over here. I already know which of these numbers is valid, so I'm going to remove the emoji now. Okay, so the result for, I'll just kind of draw like a line over it, right? So what I would get from this would be a bunch of zeros followed by a 1, right? This is for this and this. Okay, it is and, so I get 1, right? For here I get this one. For here I get this one. And for here I would get 0, 0. right? So 0, 0 is okay. And yeah, so it would be basically like if with bitwise and, well, first, so okay, and 0, right? So with is 0, um, right, return null, you can't do that, right? Now, so that handles this case for me, right? Because this is the one time it's broken where these two bits are 0, and actually it's still invalid. Otherwise, it's always valid when these two bits are 0, right? So if the bitwise and of the width and this bit mask um, is anything greater than 0, it's a problem, right? It requires padding. And since the logical and since the, I mean the bitwise and gives a number back, um, I'll do basically it's like if 0. So if it's okay, then this does not true. So if it's any other value, then it is true, and this means it means padding, right? And so bitmask would be um, zeros, right? And 0, 0. Let's see, it's 8 bytes, or it's a it's 4 bits for each. So I need to have 4 hex. I need to have 8 hex numbers here to do 32-bit, right? Right. So I think that's correct. Let me one second. I'm not. That's another thing I'm not exactly good at. Is I said again, I need to kind of look at how to properly write the hex stuff, right? So the hell? Can't I just do this, right? Yeah, here we go. Okay. Zero x free. Oh yeah, I'm losing my mind. Jeez. And also, I do want it to have all the appropriate zeros, right? Um, so it would be, as I said again, it would be 7 zeros. Yeah, 0 B 1 1 followed by. Okay, cool. So 0x3. Okay, so I guess in this case, yeah, so I guess I can actually, so the padding required is just like agglutinative. It's just going to be added atop the sum I had already found. Right. Oh, that's weird. I saw something weird. Sorry. It's just going to be add at the top the number I had already found, right? So first, I guess really what I can do is I can just go ahead and do the preliminary calculation here, right? And then if padding is required, I will determine how much padding is required here, right? Uh, and then I'll multiply that by every row, right? Or the amount of rows that there are, um, which is actually how many columns, so behind the image, right? And then I will add that to um, the size I had determined above, right? That will be my algorithm. So let's see. I just checked on my stream for a second, and I don't know why the audio does that, where it turns like demonic. It becomes like really bad quality all of a sudden. That was really weird. I nearly sounded like I'm not gonna say it, but I you know what I mean? Like you know what I'm talking about. All right. Let me see. Maybe the I don't know, maybe just like maybe I don't know, maybe I need to lower like the audio bit rate. I don't I just looked at it earlier and the video bit rate setting is a little bit like too high. I don't know if that was actually like messing up stuff, like my messing up like my ability like on the bandwidth side of things or just like the CPU and GPU, kind of the I don't know what that was happening. So anyway, let me just do a little bit of adjustments on the stream just so maybe a little bit less of that could happen. Uh, yeah. 'Cause I don't know, I don't really got anything else running. I know like there's some stuff for example, like I saw that Windows module nonsense was running. Okay, that was agitating. It was installing some nonsense, right? And it's using up a bunch of my disk and my resources. Eh, but yeah, just don't know what the deal with that was, man. Um, yeah, one sec. Actually, I mean, I think I have some earbuds. Maybe I could use those. That would improve the mic quality. Let me see. It's just kind of weird hooking them up to the computer. All right, let's see how that ends up going for me. Let me try to connect. Got connected to the streaming device. So, all right. So I got this connected now. I don't know if it's gonna let me use it as a microphone. That's literally the point. But and I've done it before, so I don't know why I don't know why it gives me like yeah, like OBS just like nearly crashed for a second when I did that. That's nuts, man. That shit is genuinely crazy. It's just like bad on Windows. I don't know. Is this thing just like not properly connected, or what is the deal there? One sec. This is the kind of thing you really do after or before the stream, but um, yeah. Why is this disabled? Yeah, this should really be my default device. Okay, I don't know why that was disabled. I had to go into control panel. Um, right. Okay, maybe now it will. I just needed to appear on OBS. There we go. Okay, so I think now it should be using um, the correct microphone device, which should be my earbuds, right? I think that should result, hopefully. I don't know if there's just an issue with my laptop's internal microphone for the laptop I'm using for streaming or what the deal is, but I hope now there's better audio quality and maybe less like transition errors. I don't know if it's a hardware problem or if it's like a broadcasting issue with like the bandwidth and stuff. Because like for example, the audio quality of the microphone is significantly higher of these earbuds on when I use them on Linux, right? But to get them to work nicely on Linux, I do have to use this like client thing, right? They obviously don't make a client for the. I'm using my Samsung Galaxy Buds, right? I'm not really a headphone, but I'm not like much of a gamer, or I'm not even really much of a live streamer either, right? So the fact that I'm just doing this is kind of like brand new to me and just like for fun exploration. Um. Anyway, so I've installed the application. I just have one earbud in. Um, Maybe I can put the other one in, and then I can do ambient sound. I don't, so the reason I like headphones and stuff I don't like is I like being able to be aware what's around me, right? But maybe the audio quality will improve if I am to use both of these, right? And I'll just put it on ambient noise so I can still hear what's around me, right? And I want ambient sound to be pretty high. In fact, actually, I'm going to set it to try to cover the outer microphone while using extra high volume, as this can cause a high pitched feedback. Okay, I'm just going to put it a little bit lower then. Uh, yeah, and I hope by doing that that I can improve the uh, audio quality somewhat. I don't know. I just don't know what's exactly causing um, the transmission problems. Okay, cool. From what I hear, it looks like it's doing better, right? I'm just gonna go ahead and do test, right? I'm going to make this like some tabular stuff. I'm already pretty much convinced that this I can just do these bitwise and to really fast determine if any padding is needed. But it seems a little bit like, oh, I found my little thing. I found this cool little hack. Usually I pick up little hacks by somebody else does it, right? I'm like, oh, I'm gonna use their hack, right? Um, let's see. Is my test for if it's divisible by four. I want to just say like so the second field is whether it's been determined to be divisible by four. Okay, so yeah. I think they have consensus. I think this is the fast method if it's just to use this bit mask, right? Okay, well, cool to see that works. So that's what I'm going to do then. So I'm going to go ahead and just put this, actually, no, I don't even have to do that. Okay, so, first of all, yeah, actually, so I can preemptively determine, so obviously, if the width or the height are zero, then this has to just be aborted, right? I shouldn't even call malloc and wait all that time, because you, what am I allocating memory for, right? impossible to make an empty image, right? So okay, so now I know for certain that it's not zero, which means I don't have to worry about this case, right? Instead, I have to, yeah. So regardless of padding, I'm going to determine what the file size will be in bytes, right? Although I think that would be like that would be two operations. That would be multiplication twice, which is a little bit of a waste. I could just do, I think the if else method is faster. It's kind of duplicating code a little bit, but it's a little bit faster. So I think instead of that, I'm not going to do multiplication. I'm not going to do multiplication twice. Because then the padding is a multiplication operation. So I think instead I'm just going to go ahead and have an if else, right? So I'm not going to preempt this at all. Okay, so I know what I realized. I had stuff in the washing machine. Um, yeah, one sec. Let me go put that. Let me go put that back. Let me put it in the dryer. Be right back. One sec. So we're back. Um, Sorry about that. I just had to maybe do the laundry. Let me just make sure that my noise cancellation is off. All ambient sound on. Okay. Yeah, I can hear the stuff around me. That's what I want, right? Alrighty. So as we were, yeah. So what I was going to do previously is I was going to preemptively calculate the file size, regardless of whether there's padding, right? But then I said I wasn't going to do that because I would do multiplication, right? And then in the branch, I have to do more multiplication. Whereas I can really just go ahead and do that directly here, right? So, so if there's no padding, then it's just 3 bytes times the width times the height, right? And so, for example, if there are if it's a 2 by 2 image, right? Then we would have 4, right? Pixels total, but since each pixel is 3 bytes, then it would actually be 12 bytes, right? Because in reality, this would be um, right. So for an entirely white image, then it would be like let's see, white is when every value is maxed out, right? So it'd be like 0xFF, right? 0xFF, 0xFF, right? 0xFF, right? So whereas this is 4 bytes, this is 4 bytes. Might tweaking out, right? Yeah, no, I would need to have it'd be more like this, right? Yeah, it'd be more like this. Um, it's like I'm really losing mine. I'm sorry. Yeah, the image would be a lot more like okay, let's just do this in binary. I'm getting a little tired. I'm probably still gonna keep programming for like another hour or so. Where it basically be like the font is too big now, so it doesn't fit on one screen, right? Let me just make the font smaller for a little bit, so I'll bring it down to like 16. Right, so we have like 2 bytes, bytes, 4 bytes, 5 bytes, 6 bytes, and then to go down by 2. So up to 12 bytes, which is the same thing as this right here. Right. Actually, so that's very direct. Um, but we're not just about the file size. We're also talking about, for example, how much space it occupies as well. And that's actually easy to determine. Oops. Just by we can go ahead and read what we've always been reading, right? It would be here, right? So this person was actually nice enough to tell you how big the whole thing is. So we would have 54 bytes from the info header and the header combined. Um, and this would still be here. Oh, wait, no. Actually, so the color table is actually just outright not going to even get put in there. So actually, that means I can go ahead and rewrite this struct a little bit. Because the color table is not supported. The color table is not going to exist at all. Because it's only present if the bits per pixel. Um, so I'm just not going to put this guy at all, right? Because I'm not doing anything that supports this. I'm doing only 24-bit um, BMP. Okay, cool. So in that case, I know for certain the preliminary size is 54 bytes thanks to this 14 bytes and this 40 bytes. This guy doesn't get put in here at all. And then we're just down to the pixel data. So it would be 54. Yeah. Okay, cool. So that's very easy, right? Now, if padding is required, then it's a little bit different, I guess, because you would do 54. Um, yeah, so I'll just go ahead and I'll go ahead and do a little bit extra stuff here. So go ahead and put put a variable. And by default, it will be 0, but if padding actually is required, then and this is in bytes. And then I guess would just be the result of the bit mask, right? Um, so I don't want to do that twice. So I guess actually, yeah. So padding required can actually just be the result of this guy, actually. Okay, so and that actually makes this a little bit more legible. Where now it's like, really padding required, right? So in which case I can actually just remove this, right? And this is the case where no padding is required at all, right? Because if padding required is 0, then this is not true, right? Then we go down here instead. Otherwise, padding is required. And I know how much padding is required because padding required is determined by the bit mask here, the binary and. And so, for example, as I was writing earlier, so let's say we're going to just do 5 wide, right? Uh, then this thing needs to have oh wait, so this is yeah, I didn't do the mask here. This thing is 1 over, right? So this is more like overage, I guess, because this is 3 over. So this would actually be more like 4 minus padding required, right? Um, yeah. So actually, what we'll do is if overage So amount over 4 byte alignment, right? And now it's a little bit less legible because now it's like if amount over 4 byte alignment, right? But then padding required can we don't need that variable, right? So it would be this plus 3 times the width plus the extra padding, right? So I'm going to have to replace the variable times the height. That's the formula, right? And so it would be then 4 bytes, right? Minus amount over 4 byte alignment, right? I believe that's true. Like for example, if the width is 5, right? And then let's just say the height is like 5 as well, right? So okay, so in this case, then it would get 3 bytes of padding, right? For a total area. Yeah, so this would be just 1, right? So essentially this would be width plus 3 because there needs to be 3 bytes of padding, right? Um, it's 8, which is 8 byte alignment, right? Then it's 4, 5 plus 4 minus 1, that's 8, right? So then 3 times width, this is the 120, I think, right? Um, which I believe is correct, right? Yeah, I mean it has to be. Okay, well that's that, I guess. This could really be kind of like I guess like this, right? I guess what I'm getting at is I don't need braces, right? Okay. Okay, so that would be the file size. Um, cool. All right, now, so we can write that, right? And the file size is actually written. And the signature is written, so now we can go on to reserve. To my knowledge, reserve needs to be set to 0, so I'm just going to go ahead and set reserve to 0, right? Offset from the beginning of the file to the beginning of the bitmap data. My understanding is that that would be pixel data, right? Um, it's weird how there's a file size attribute and then there's also
image size. So I guess image size, um, well, this is the compressed image size. I don't know. So I guess that's just gonna get to 0 as well. Anyway, data offset is where the bitmap data begins, which I think is where the pixel data begins, right? And since there's no color table, that should just be at an offset of 54, right? Because yeah, if the offset is 0, then we're just here. So 54 would be at the end of this. Um, yeah, where everything else starts. So I'm gonna set the offset to 54. And now we're working on the info header, right? Okay, so size. I think it's just 40. I don't know why else that guy is really there. All right. Now the width is going to get set to the width. That's kind of obvious, right? The height, I think that's to the height. Now, I don't know what planes is. It looks like it says it's supposed to be something equal to 1, so I guess I'm just going to do that, right? I'm not going to use compression, so no compression. And since there's no compression, this is going to get set to 0 because there is no compressed image file size. There's just the image file size. Now this guy is weird because I don't know how to actually deal with this. Um, like pixels per meter. I thought that was specifying. Um, that 1 second, I thought I just saw something. I don't know. Oh, okay. Sorry, that was weird. All right. Yeah. So I need to figure out what this is, right? Okay, this guy. So this guy's just saying that you can just put this value. Should be the DPI, right? So listen, this guy wrote a little bit more of a thing. I think of it this way: the image bits within the within the BMP structure define the shape of the image that image using that much data. In other words, that much data describes the image. But information must then be translated to the target device using a measuring system to indicate its applied resolution in practical use. So, for example, if the BMP is 10,000 pixels wide and 4,000 pixels high, that explains how much raw detail exists within the image bits. However, that information must then be applied to some targets. Use the relationship to the DPI and its target to derive the applied resolution. If it were printed at 1000 DPI, then it's only going to make an image with 10 inches by 4 inches, but one with extremely high detail to the naked eye, more pixels per square inch. Like, if it's printed at only 100 DPI, then you'll get an image that's 100 inches by 40 inches with low detail, fewer pixels per square inch, but both of them will have the same overall number of bits within. You can actually scale an image without scaling any of its internal image data by merely changing the API to non-standard values. Using 72 is as a throwback to ancient techniques, which is not really relevant in moving forward except to maintain compatibility with standards, as modern hardware devices often use values for their fundamental relationships to image data. For video screens, for example, Macs use 72 DPIs, default Windows use 96, others are similar. In theory, you can set whatever you want. Be warned that not all software honors the internal settings and will instead assume a particular size. This can affect the way images are scaled within the app, even though the actual image data hasn't changed. Okay, let's see what this guy linked is. Okay, I don't know what the hell just happened. Okay, TWIP, right? 20th of a point. That's a cost. A pixel is a screen-dependent unit standing for a picture element. A pixel is a dot that represents a small graphical measurement from the screen. TWIPs are the default units of measurement in Visual Basic. Okay. And let me see. Just want to, I see DPI, but I never really acknowledged it or thought about what it meant, right? So it's dots per inch, right? DPI. Yeah, that makes sense. It's a measure of spatial printing, video, or image scan, or dot density in a particular number of individual dots that can be placed in a line with a span of 1 inch. So I think this is probably the section I was really looking for. In printing, DPI refers to the output resolution of a printer or image setter, and PPI refers to the input resolution of a photograph. DPI refers to the physical dot density of an image when it is reproduced as a physical entity, for example, printed onto paper. A digitally stored image has no inherent physical dimensions. Okay, yeah. Because in inches or centimeters, some digital file formats record a DPI value, more commonly a PPI value, which is to be used when printing the image. This number lets the printer or software know the intended size of the image. Or in the case of scanned images, the size of the. Okay, so this is really just for like printer stuff. I don't care about the printer a whole lot. Not really intending for anybody to be printing anything. I guess if you want, you can set the DPI yourself. Um, so I don't know. I might just set it to whatever this guy is saying then. I'm just going to put them at 2835 then, I guess. All right, cool. All right, so now we can continue. All right, colors used. I'm going to set this guy to let's see, I guess 16 million, right? Um, it's 24 bits, right? So I'd be filling up all 24 bits. Um, well, let me see. So that'd be 0x. I need to do so one hex is 4. I need to do 4 hex values, right? I need to do 6 because 24 million, right? Or 24 bits, right? So all 24 bits are filled. So 16 bits, 20, 24 bits, right? I think just to confirm, if I were to open up Python, right? Oh, what have I done? Oh, I just scrolled down, right? Okay, so if I were to do Python, right? If I do int uh, fff, right? 16, and this number is, yeah, 16 million, right? So that's fine. And I'm going to say 0 because I'm just going to say all colors are important, and none of this matters, right? Okay, so um, now I can attempt to allocate the memory for the characters for the image data, right? So now I can do BMP dot pixel. It's not important, but I'm just going to put that there anyway. No, fuck that. It's a byte, right? Malloc is already measured in bytes, so I can just put the direct measurement, right? Um, now the BMP. What the fuck did I just hear? I don't know if that's the audio canceling of these headphones. I'm going to take out the second earbud because I don't know what the hell that was. Started having me listening to weird stuff. Weird little noise. I don't know what that was. I didn't like that. Actually, I might just forego the headphones for a little bit. I don't like wearing headphones. I just don't like wearing headphones. Internal microphone on my laptop. Sorry. Eh, I just want to make sure that there's no, it's not maxing out. Previously, I had the, uh, put a little bit of a kind of limiter on that. I decreased the audio. This is the K-Lac video I've been watching earlier to kind of help inform some of my stuff. And let me just check for the quality of the audio on the stream. I just want to make sure that switching to this has not been messing anything up, right?
Okay, cool. So let's go ahead.
Connect to the Wi-Fi network. You might want to check the connection settings in the Google Home app.
Really, man? I hate that thing, bro. It just goes off. I won't. Nobody will be talking to it, and it's just like, all right. Okay. Anyway, yeah. So it should just be file size minus 54, right? Because when we calculated the file size previously, it's it's this plus 54, where this would be the pixels, right? Um, yeah. Now, I guess it's pretty important to make sure that you don't write at the padding areas, right? And actually, uh, well, let the user do that if they want to, right? Let the functions, they can manipulate the data directly if that's what they wish to do. If they wish to, for example, place a data where really it's just for padding. But what I will do instead is in the, for example, the place pixel function, will not permit placing a pixel at an offset that is for padding, right? Because I can calculate where all the, I can index all the padding, right? Or it's a very simple check because you can just look at the dimensions of the file, right? Uh, yeah. All right. So yeah, this needs to be this much memory, right? So then, of course, if I get null, then there's not enough free memory to represent this picture, right? In which case I need to just basically free the entire BMP and return null, right? But first I'll print out an error, right? Right. Um, that is the index function. Uh, so I kind of just want to make sure that it works. But then I need to define the other functions, right? I don't exactly want to do that. Or I don't have time to do that right now. So first, what I guess I'll do is I'll just have the instantly return some dummy value, right? This is just because it's not implemented, right? Right. Um, well, let's try to build up.
Okay, yeah, so it failed. Um, Now I'm just getting a lot of yeah, so I added all the extra stuff. This doesn't really matter to me. I knew that there's going to be like warnings for this because getting a lot of warnings, right? Oh, okay, so this is just a typo. That can actually be fixed easily. And this would be a type of UN32V. Okay, that's fine. So I'm gonna change that. I don't know what the specifier would be. Yeah, it's unsigned in, so I guess I would just put %U, I guess. I didn't know if there was some special specifier I need to put or whatever, but I guess ultimately the thing really just is 4 bytes. So yeah, and this is just unused parameter because redefinition of green. Okay, so I need to make that blue, right? So let's go ahead and just fix those simple errors, right? So where's green defined twice? Yeah, right here. All right, so this should be blue. And then I think everything else was an issue within uh, the C file, right? So I think I said it was on line 63, right? Yeah, and that's from earlier here. And then this needs to be not ZU, but just U, right? Okay, so now I'm just gonna get a bunch of warnings, right? Apparently these have conflicting types. Um, hmm, where is the conflict? Besides that, that's the only warning. I mean, the only error. I believe so. Okay, so draw a line, right? I guess this function. I don't know, did I write this myself or okay? Anyway, direction. I don't know. Does this guy just not have the direction? No, it does. I don't understand where the conflict is. Okay, I might have to turn off this W all shit because it's kind of like it's getting a little bit annoying now. It's like really hard to parse through what the problems are. Because I know that the function is not defined yet, or just whatever, but I don't care right now. Okay, so I see that I need to put why would I put STD depth? I already have STD depth. Well, I don't have it already, but I don't know why I need it, right? I guess it's because I haven't included like STD lib and stuff, for example, right? So let's see. I'm going to do I'm getting sleepy for real. I feel it. There we go. So I don't have file. I don't have STDIO, right? Okay, cool. It's basically BMP destroy functions as well. Yeah, so hopefully that works. Right, so I'll do is okay, so I get set allocates and whatever. And, okay, cool. Well, it's probably a good place to lead off. I'm going to likely continue this maybe tomorrow or Sunday or something, or in a couple of days. Um, yeah. All right. Thank you for watching. It's kind of a little bit of a less focused stream this time. I intended to start earlier, but I don't know what happened. Sorry. So, not as much work got done typically as I would like in here. I think it's because I spent a lot more time kind of digging through the logic and just trying to uh, be clever and do stuff right. Like, for example, this took up quite a bit of time doing this, and then other things. I was trying to improve the audio problems and trying to improve the video quality. But yeah, so I'm going to continue this topic. I'm also going to continue, of course, with the Markdown transpiler as well. But since this is pertinent to a current project I'm working on, I might take greater focus on this one, and then the Markdown transpiler. I'm also naturally going to continue to play games as well. It's really just what I kind of end up doing with the evening and stuff when I'm on my own. So yeah. Anyway, thank you for watching. As always, I'll be ending the stream shortly.